So in today's video, we will be exploring what energy is and what forms energy take. So on this first slide, you see four different common types of energy, ones you may have seen before. We have the energy of this mousetrap springing. We have energy of electricity. Maybe you've seen static electricity. Energy of matches being lit on fire. And then energy of a light bulb. These are all forms of energy these are all forms energy can take. So we have mechanical energy, we have electrical energy, we have chemical energy, and we have light energy. And these are all different types of energy that we'll be exploring today. So here's our definition of energy. Energy is the capacity of an object to do work. Now, you've heard of the word work before, but you haven't thought about it in physics terms. In science, work is defined as movement of an object. If an object has the ability to move, then it's doing work. And if an object is doing work, it needs energy. So energy is required for work, and work is simply defined as movement of an object. So if an object is moving, again, it is doing work. Sometimes the entire object might be moving or doing work, like as in a roller coaster. Sometimes just a few molecules might be doing work, such as in, say, heating of a substance causes the molecules to move more. Or even just subatomic particles, protons, neutrons, and electrons, they can just individually be doing work. So we have the example of the roller coaster moving. That would be the entire object doing work, and it requires energy for this roller coaster to move. And another example is the movement of molecules. This picture would be an example of a solid, and this picture would be an example of a liquid. Well, to take a solid from a liquid, you need to add heat. Heat is a form of energy, so by adding energy to the substance ends up doing more work. And work is, again, movement. So look at how the movement changes when you add heat to something. So we have less movement, more movement. Heat is energy, work is movement. So here's the major rule of energy. Energy can never be destroyed. You cannot break down energy, you cannot destroy it. All you can do is change its form. Now the catch is when you do change the form of energy, oftentimes some of it is dispersed into the environment in a way that we can no longer use it. For example, all fuels like fossil fuels, oil, gas, in this case rocket fuel. When you light it on fire in a combustion reaction, you get a lot of energy out of it. We get enough energy to lift this rocket into the outside of the atmosphere. However, that combustion reaction releases energy and changes that energy into an unusable form. In this case, the energy is now held in water molecules and carbon dioxide molecules, and those are two molecules that we don't have the ability to extract energy from. So oftentimes energy isn't destroyed, but it's changed into a different form. We cannot destroy energy. It follows the same laws as the law of conservation of mass. The law of conservation of energy states that we cannot create or destroy energy, only change its form. Another great example of this idea is a food chain. You all have seen food chains before. We know that in a food chain we have producers, consumers, primary, secondary, and tertiary, all starting with energy from the sun. And really it should be stated that all energy on Earth is from the sun in some way, shape, or form. So the sun delivers energy to a producer, which then turns the energy into some kind of food. In this case, it's glucose produced through photosynthesis. So now the energy has just changed form. It's changed the form from sunlight, light energy, into glucose, which is biological energy. And now that biological energy has changed forms when the primary consumer eats the producer. So now it's changed forms again. Secondary consumer now eats the primary consumer, and the energy has changed form again. In this case, the entire mouse would be the energy. So it goes from a plant, glucose, into the primary consumer, secondary consumer, tertiary consumer, and look, even back to the decomposer. Now the decomposer gets energy from the tertiary consumer, and it all cycles backwards. So we don't ever lose that energy, it just changes form. And each time it changes form, some of it's dispersed into the environment. So while we can no longer use it, the energy is not destroyed. And that's a very important fundamental concept. You cannot destroy energy, just change its form. So there's a bunch of different types of energy. The first type of energy is gravitational energy. And remember, as we continue, keep in mind that energy is needed for work. And work is the movement of an object. So you'll notice a common pattern, a common thread between all of these types of energy, and all of them you'll see something doing work. So right here we have gravitational energy, an object moving due to gravity. It's doing work. In this case, the apple is doing work by falling towards the earth as a result of gravity. So there's gravitational energy, something falling as a result of gravity. Second type of energy is heat energy. Molecules begin moving rapidly, and that generates heat. So you saw a picture of heat energy back on this slide. As the molecules move, they do work, and that generates, and then heat energy is required for that generation to happen. And we have a few different types of heat transfer: conduction, radiation, convection. These are all terms you've seen before, and now you can apply them to the idea of energy. Next is electrical energy. This is what's used to turn on your computers, to power your phones, to turn on the lights. And now this is moving electrons along a path. So now we're down to subatomic particles moving or doing work. So energy from electricity is required to move these electrons, cause the electrons to do work. So again, I want to keep on emphasizing that work is movement of an object, and work requires energy. Here we have the entire object moving, mechanical energy. This is when an object is just simply moving from point A to point B. This roller coaster is lifted up by a pulley, and then it's brought back down. So the electrical energy is now converted into mechanical energy of that pulley pulling it up the roller coaster, and as it falls, it releases that energy. So mechanical energy is the moving object. Another example is if you were to push a large object. You're taking biological energy that you got from eating food, and now you're pushing an object in the form of mechanical energy. So simply moving an object is mechanical energy. Finally, chemical energy. Chemical energy is when molecules change from one form to another by bumping into each other or moving apart. So again, the molecules need to be doing work. They're moving, and that requires energy. In this case, it's chemical energy. So fire is the perfect example of a chemical reaction. That is energy, but it's considered chemical energy. So fossil fuels come from biological energy because they came from living things. So we convert biological energy into chemical energy, which often is converted into heat energy. So as you see, these energy forms change, and as you watch this video, one of the main skills you're going to be able to do is to predict the path of energy as it's converted from one form to another. So that's it for the different types of energy. So as you complete this guided practice and you see 3 different types of energy, keep in mind we've discussed biological energy, heat energy, electrical energy, mechanical energy, chemical energy, and gravitational energy. Keep all of those in mind as you work on this activity.